Right, we're going to do the last question from the South Downs College vectors test that we did in 2018, which actually the main was from June 2010 at Edexcel. Now, first bit we've got fairly a gift really. We've got 2 points A and B. Okay. And he wants the vector A and B. It's given us the position vector of both of those. Well, that's no problem. So we've got the position vector of OA and the position vector of OB. So it's a fairly straightforward thing to work out AB, because that's equal to, AB will be equal to minus OA plus OB. Okay, so we're basically taking the vector A from the vector B. So that's 5 take away 2, which is 3. 2 take away minus 1, which is 3. And 10 take away 5, which is 5. Right, so that's a nice easy start to the question. Part B isn't going to worry us too much either. We know that the equation of a line is basically any position plus lambda times direction vector, or a direction vector, so well, any position, well, we've got 2 possible points on the line. We could choose A or B. Let's choose A. So that's 2 minus 1, 5, position of A, plus lambda times a direction vector, and we've worked out AB is going along that line, so that's 3, 3, 5. So, nice easy start. Vectors questions quite often are like that, where they ease you in, and then some more tricky bits later. Right, so part C, dot product thing, we probably need to take a little bit of care with directions here. We've got 3 vectors. Let's draw the 3 vectors. A, let's put B over here, and I'll put C over here. Right, and we can just, it wants us to work out this angle. So we need to make sure that we get directions right. So let's have them both going outwards like that, so that they're in the right directions, because we need to show it's 109. It's no good just to kind of fiddle it. We've got to show that what the vectors are. So AC, again, that's minus OA plus OC. So it's basically taking A from C. Sorry, that's the vector D here. Apologies. Okay, and it wants BAD, so the vector D. So again, we're taking the A from D, so that's minus 1 take minus 2, so that's minus 3, and minus 1, so 1 take away negative 1, which is equal to 2, and 4 take away 5, which is equal to minus 1. So we've got AD and we've got AB, so we've got these 2 vectors here, and that's where we're going to use the dot product for. So basically the cos of the angle in between, angle BAD, is equal to the dot product of AB AD over the modulus of AB, the modulus of AD. Well, the dot product, 3 times minus 3, 3 times 2, and 5 times minus 1. Okay, and then the mod of AB, the modulus, the size of AB, that's 3 squared plus 3 squared plus 5 squared. And the size of AD, ignore the minus, 3 squared plus 2 squared plus 1 squared, which comes to minus 9 plus 6, that's minus 3 minus 5, so that's minus 8, over the square root of 43 and the square root of 14. So we've got cos of that, and I think it's pretty convincing now. I wanted us to show inverse cos of this thing here will give us the 109 degrees as required. Right, so not too bad either, a bit of work, but still fairly routine. Now, some more questions here. It says that C is the points A, B and D together with the point C are the vertices of a parallelogram, where AB is parallel to DC. So basically, we've got some point here, C, which makes it a parallelogram. And so for part D, still not too challenging really. It wants the position vector of C. Well, if we can find the position vector of D, and we know the position vector of D in fact, given in the question, then we just need to add on the vector DC. So if we know the position of D, add on DC will get us where we want. But we know that DC is the same as AB, and we've worked that out from before. So that gives us AB was 335 and OD was minus 114, OD was, and AB we worked out earlier as well in part A was 335. So those come together to 249. Okay, so we're getting to perhaps a slightly more challenging bits, but it's interesting that's already got us 10 marks out of the 15, so we're doing pretty well out of this so far. Right, now, then it talks about finding the area of this parallelogram. Okay, so the area, this is part E now, is equal to, well, if it were a triangle, it'd be half AB sine C, but it's a parallelogram, so basically we've got two of these. So that's the mod of AB and the mod of AD times by sine 109. And the good thing of presenting your work quite nicely from before is we've got these numbers already, because the mod of AB is square root of 43 and the mod of AD is equal to the square root of 14. So that's the square root of 43 plus the square root of, times the square root of 14 sine 109, but I've got that number stored exactly in the calculator, and that comes to 23.2. Okay, to three significant figures. Right, now for the question on the shortest distance, and now I'm going to do a diagram here, only 2 marks for it. Right, so we've got our line L1, our line L, okay, and we've got a point on that line which we know, and we've got a point D. That's our point A that we know. But we've got a point D here that we've just found, and we've just found this angle here, 109 degrees. Okay, and it wants the shortest distance. So that will be this distance here. Let's call it D. Now, quite a few people, good students who know how to work with vectors really well, actually made this a little bit more difficult for themselves. Basically, we know the point D is equal to minus 114, and then they knew they just made a general point here, and they found the point P by putting that into a general thing and find the value of lambda, and they found point P by just using the dot product and things to work out the coordinate of point P. There's a well-known method for doing that. However, it would be making life much more difficult. In fact, the value of lambda worked out quite unpromising. So it's a lot more work than needs to be for 2 marks to actually work out the coordinate of P. We can do it. We use a dot product. We use the fact that we know the direction of this is 3, 3, 5. We work out the general point on this line, and work out the value of lambda, which gives us P, and then we're using Pythagoras to find the difference between P and D. But we don't need to do that here. We have already worked out the length AD. The length AD, so I had it here, AD, using Pythagoras, is the square root of 14. So we just need to do a bit to work out the shortest distance. We need to, let's call that angle here, that's 180 minus 109, which is 71 degrees. Not exactly 71, but I've got that number stored on the calculator, so that's fine. So the shortest distance is going to be equal to D equals to square root of 14 times by, and we're using just normal SOHCAHTOA here, it's the opposite, so that's sine of 71. But as I say, I've got that actually stored exactly in the calculator, 180 minus that 109, and that comes to 3.54. Very significant figures. Okay, so that's that question done. Wasn't too bad really. We started off with some easy stuff, a little bit trickier towards the end, but a good diagram will always help in picturing what's actually going on. Okay, if you're reasonable confident in practice, it shouldn't be too bad. Okay, hope you found it useful. Bye.